Hello everybody, today we will be entering chapter 4, which is on work, energy and power. So there are three subtopics, if I'm not mistaken. I feel like there are three subtopics. Yeah, so there are three subtopics in this chapter, and the first one is on work. So in this subtopic, you have to be able to state what is the meaning of dot product for work, define and apply work done by a constant force, and lastly, determine the work done from a force displacement graph. Right, so work done by a constant force is defined as the scalar product between force and displacement of a body. So that is the definition of work done. Okay, this might be asked in UPS lah, but not in PSPM. PSPM is focused mainly on calculations. It can also be defined as the product of the magnitude of displacement times the component of the forces parallel to the displacement. Okay, so mathematically it can be written as shown here. I should use red color. Okay, so mathematically it is written that way, where F is the magnitude of force, S is the displacement of the body, and theta is the angle between F and S. So between F and S, which is this is the displacement, so your theta is here lah. Okay, all right. Work is a scalar quantity, so it is a scalar quantity. That's why F here is focusing on the magnitude of the force. It is not asking about the direction. So because work is a scalar quantity lah, it has the unit of Newton meter ataupun joules. So 1 joule can be defined as the work done by a force of 1 Newton, which results in a displacement of 1 meter in the direction of force. So that is the definition of 1 joule. Okay, soalan dalam UPS, sometimes it will ask you what is the definition of 1 joule juga lah. Okay, please note that work does not have direction because it is a scalar quantity, but it can be positive, 0 or negative depending on the angle theta lah. Okay, so if the work done is greater than 0, which is positive, the work is done means the work is done on the system by the force where energy is transferred into the system. Bila work done is negative, maksudnya work tu is done by the system. Okay, so maksudnya work sekarang ni kena buat oleh system instead of work being done on the system lah. So energy is transferred from the system. Okay, so these are some of the situations where you will see ataupun you will try to solve in our questions lah. Okay, so if in this case force is now parallel to the displacement, so remember angle theta is equal to theta is the angle between F and S. So theta is now equal to 0 lah. So bila theta equal to 0, work is 50 Newton meter for this case. So maksudnya ada work is done lah, ada work done. Okay, in this case theta sekarang ni 60 degree, so ada work done. And then we have when the force is parallel to the displacement, so maksudnya theta is 90 degree. So bila itu berlaku, there is no work done. Sebab sekarang ni work will be present if they follow the direction of displacement ataupun at an angle lah. Okay, untuk sekarang ni pula kita akan tengok where the force is now pointing to the left. You are measuring the 120 degree ni sekarang dari displacement pergi force. Okay, so direction of displacement is dari displacement pergi force. Okay, for this case pula sekarang ni dari displacement pergi force, maksudnya ini adalah 180 degree. Okay, so mesti consider lah, jangan kamu pandai-pandai letak sekarang ni theta ni parallel, lepas tu kamu letak 0. Tidak, sekarang ni dia mesti follow dari displacement pergi force. Sekarang ni diorang bertentangan arah, so work is present lah. Okay? Okay, so let's look at an example. Not an example. I mean the case where a person holding its briefcase does no work on it because there is no motion. So if you're holding something, for example, like this, and then you're not moving, there are no work done. But if you are moving with the briefcase horizontally at a constant speed, and the force does no work on it because the force is perpendicular. to this displacement. Okay? Kiranya kalau kamu bawa something and then contohnya kamu bawa kotak and then you are moving at this displacement, then you will have work lah. Okay? And then C, when the briefcase is lowered, the work done on the briefcase by the generator, which is this one, will be negative because force is in the opposite direction with this displacement lah. Okay? So kiranya kalau kamu nanti force facing up and then displacement is facing down, your theta is measured like this. I mean, I don't really mind. It's up to you whether you want to go force to displacement ataupun displacement to force. So, tapi theta tu equal to 180 degree lah sebab sekarang ni dorang in the opposite direction. Okay? So, please note that work done by forces that oppose the direction of motion, such as friction, will be negative. So, work done by friction is negative lah sebab they oppose the direction of motion. And then if there is more than one force acting on a body, the total work done is defined as the work done by all the forces acting on the body ataupun the scalar sum of all those quantities of work. Contohnya macam ni lah. Okay? Alright, let's look at the work done from a force displacement graph. So this is a force against displacement graph, and the area under this graph is the work done lah. Okay, so that's how you calculate the work done from a force displacement graph. Okay, now let's look at example number 1. So you push your physics reference book 1.5 meter along a horizontal table with a horizontal force of 5 Newton. Okay, so given is the force, which is 5 Newton, and then the displacement is 1.5 meter. And lastly, they tell you the friction force is 1.6 Newton. So we have to calculate the work done by the 5 Newton force dulu. Okay, so that is just work done Fs cos theta. So if you look at this diagram, the force is in the same direction as the displacement. So the angle will be 0 degree. So that is 1.5 cos 0 degree. So you will then get the value 7.5 joule. Okay. Next, you have to calculate the work done by the frictional force. So that is work done equal to Fs cos theta. So now let's look at the friction force and the displacement. So both of them are in the opposite direction. So our angle will be like this. So theta is equal to 180 degree lah. So that is 1.6, 1.5 equal cos 180 degree. So that is equal to negative 2.4 joule. Okay, so why is it negative? Because for friction force, it opposes the direction of motion. So work done untuk friction mestilah negative. Okay, and then we have to calculate the total work done on the book. So the total work done is equal to the work done by the 5 Newton force plus the work done by the friction force. Okay, so that is just 7.5 plus dengan negative 2.4. So you will get the total work done to be equal to 5.1 joule. Okay, ataupun kamu juga boleh buat cara total work done, sum of work done is equal to the net force times dengan the displacement. So that is F minus F times dengan 1.5. Okay, nanti kamu akan tengok yang untuk the net work done, net force untuk work done, kamu akan apply untuk the one yang ada motion saja, the one yang ada velocity. Usually kalau tiada velocity tu, dia tiada lah, there is no work. That's why we are usually focused in net force untuk the component yang ada motion. Example number 2, a box of mass 20 kg moves up a rough plane which is inclined to the horizontal at 25 degree. It is pulled by a horizontal force of magnitude 250 Newton. The coefficient of kinetic friction is given. Remember, the coefficient of kinetic friction is not the force. Okay, some students pergi tulis yang they declare that this 0.3 here is the value of F. It is not, okay? It is the coefficient, which is mu k. Okay, so now it is a rough plane inclined to the horizontal at 25 degree. Okay, sekarang kita assume kita punya angle inclined plane macam tu. So this is 25 degree. And then there is a box. Not they are. So there is a box. Let me just draw it here. So there's a box macam ni. Why isn't this a block? Itu block kan. Okay, so sekarang ni this box here is here. Okay, so it is moving up this plane. Okay, so dia sekarang ni dia bergerak pergi atas. Okay, so astaga, lambat pula, sorry. So it is going up here. Ini bukan now, it's not, dia bukan ada dua box dia just ada. Ini adalah after. Kiranya macam dia akan pergi di sini nanti. Macam tu lah. Okay, so this is the diagram. Okay, so now what do we need to do? We need to draw the free body diagram. Okay, so always get used to drawing a free body diagram because it helps you a lot in determining what forces are in the x and y component lah. Okay, even though work is not a vector quantity, it's good to know the situation of the diagram lah, of the diagram of the situation, begitulah. Okay, so now this is going up, so meaning the acceleration is here, also the displacement is going that way. Okay, so now we are gonna draw an x and y component, x and y axis ish. Okay, so sekarang ni kita akan lukis x and y axis. Okay, so we are gonna put it somewhere here. I will be using a different color just so that you can see lah what are the forces. I think I'm gonna use is orange helpful or maybe blue? Blue lah. Okay, so now there is always a weight force to the block because the block ada mass. Okay, so that is there. And then we have the normal force because the object is in contact with the surface. Actually, I'm gonna use a bigger size punya pen. So this is here. Okay, so this is the normal force, always perpendicular to the surface. And then what? And then it has a horizontal force. So the horizontal force is dia kena tolak lah, so kiranya horizontal force is somewhere begitulah. Okay, nak boleh pula ambil. Okay, so that is the horizontal force, and then it has friction because it is a rough surface. So this friction is slowing down the motion of the object lah. Okay, do we have anything else? We need the angle, so our y component is the one that is attached to the normal surface. Sorry. So this is 25 degree. So how about this one? What is this value? It should be 25 degree as well. If you remember maths, kamu akan tahu itu akan 25 degree. Okay, so this is the normal force, this is the kinetic friction force, this is the external force, and this is the weight force. Okay, all right, so now given is the displacement punya value, which is equal to 3.8 meters. So what we need to do is we need to calculate the work done for force, gravitational force, reaction force, and frictional force. Ada salah eja lah. I have to edit this before I give you. Frictional. Okay, so now we have to calculate for force dulu lah. the external force. So I'll just label that WF equal to Fs cos theta. Okay, so remember, theta is the angle between the force and the displacement. Sekarang ni, nilai F with the displacement berapa degree? Kiranya displacement ni sekarang berada di sini. Displacement dia is along this block here lah, okay? Macam mana lah ni? Okay, macam tu. Okay, so sekarang ni displacement is here. So from the force to the displacement, the angle is 25 degree lah. Okay, so kita akan letak F is 250 times 3.8 cos 25 degree. Okay, so dapatlah jawapan dia 861 joule. Okay, next we have to calculate for the work done by the gravitational force. So now gravitational force is talking about the weight. Okay, so about the weight, that is weight as cos theta. Sekarang ni weight is equal to mg as cos theta. So sekarang ni berapa nilai theta itu untuk mg? So this is our displacement. So the value is 90 plus 25. So 90 plus 25, the angle is from the displacement pergi the force, so that is 115. Okay, so M is berapa sudah? M is 20 kilogram. So 29.81, 3.8 cos 115 degree. Okay, so that is 90 plus 25 lah. Kan? Berapa ka tu? Ya, betul lah bah. Okay, so jawapan dia negative 315 joule. For the angle, always remember you measure it from the direction of the displacement to the force. Because if you measure it this way, it is saying that this box is going to this side instead of this one. So please remember to determine it based on the arrowhead lah. So okay, so it's from the arrowhead to the arrowhead, not the bottom. Apa ni nama dia? Bukan dari sini pergi di sini lah kiranya. Okay. Alright, so question 3 pula, we have to calculate the work done by the reaction force. So reaction force is N. So that is work done by the reaction force is equal to what is it? Okay, so N as cos theta. Okay, so what is that value of theta lagi lah? So again, from here to here, it is 90 degrees. So when it is 90 degree, the work done will be equal to 0. Okay, so tiap kira pun. Kau tulis je lah begini. Cepat. N as cos 90 degree equal to 0. Okay, and then the fourth question, it is work done by the frictional force. So the work done by the frictional force, WF, F as cos theta degree. So that is sekarang F ni dari F dengan displacement dengan the kinetic friction force, it is 180 degree. So this is F berapa tadi? Mu Kn kan? Mu Kn as cos 180 degree. Okay, sekarang ni kita ada nilai ni mu K, but we don't have the value of N. So what is N? So kalau kamu ingat, kita boleh refer N is from the Y component. So there's no movement in the Y component, so you can equal it to 0. So N minus mg cos 25 degree minus Fk sine 25 degree. Okay, so this one, Japan, I am, betul lah. Okay, so that is n is equal to, apa saya tulis ni tadi? Minus fk sine 25 degree. Kenapa fk? F lah. Patutlah bingung. This is F sebab external force sine. Yeah. Okay, so n is equal to F sine 25 degree plus mg cos 25 degree. Begitu. Okay, so dapatlah F sine 25 degree plus mg cos 25 degree. Darab lagi dengan cos 180 degree. I'm gonna padam this. Cos 180 degree, so you will get negative 323 joule. Okay, so this is where you apply both chapter 3 and chapter 4 in one question lah. Okay, then what else? You have to calculate the total work done. So the summation of work done is just the addition of all forces lah. G N F. Okay, so dapatlah jawapan dia. The summation of work done is equal to 223 joule. Okay, now we are going to apply chapter 2 pula, which is for question B. If the speed of the box is 0 at the bottom, calculate its speed when it traveled 3.8 meter. So sekarang ni apa yang 0? Initial velocity dia equal to 0. Okay, sekarang initial velocity dia equal to 0. We have to calculate what? We have to calculate the final velocity dia berapa. So sekarang ni kita tidak ada nilai time. So we can use what? We can use the equation yang tiada time lah, which is v square u square plus 2as. Okay, so sekarang ni kita boleh calculate the acceleration. Macam mana kita mau calculate the acceleration? Kita akan guna total work done equal to mass Fs. Okay, so dari sini kita tahu force is equal to m darab acceleration darab dengan s, which is the displacement. So total work done tadi kita dapat 223. So darab equal to the mass of the block, which is 20. Acceleration is what we are looking for. S is 3.8. So dapatlah acceleration equal to 2.93 meter per second. Okay, bila kita dapat this acceleration, sekarang barulah kita tidak perlu cari nilai x and y. Kita boleh just directly guna ni acceleration untuk cari nilai v lah. Okay, so v is equal to 0 plus 2.93 times with 3.8. So kamu akan dapat nilai v to be equal to 4.72 meter per second. Alright, so that is the solution for example number 2.